So I think with these breaks and everything, it's a little bit like the weekly television show. And so when the television show starts, first you get a recap of the highlights of the last episode you may have missed, and then we sort of start again. And I think that one of the aspects that Shane brought out is that there's this huge transformation going on that really is causing many IT organizations to struggle. And there's a couple of aspects to this, and we're going to be digging into all these in more detail as we move through these presentations. So first of all, there is this trend about a movement to cloud. A lot of people doing virtualization, and that's maturing into a cloud process in their organization. There's another aspect about big data, which we didn't really cover this morning, but that's also something which is a part and parcel of this drive to cloud. All the social media, which you're very familiar with, is actually a rich source of information about customers and customer behavior, and that really is influencing a lot of what traditional enterprise IT is focused on. And so these are changes which are coming into the enterprise. At the same time, the enterprises themselves have a whole list of problems. And the enterprises have organized themselves for years around silos of network server storage, and they've really optimized what network and server and storage is, but what they haven't optimized is the white space that goes between those silos. And because that white space exists, if you're going to go and do anything in the enterprise environment, you've got these long processes to go and do things. And that's why things take so much time. It's not that it's not servers are inefficient or the storage organization is inefficient, but it's actually the white space of getting them all to work together in a coordinated fashion. That's why it takes a month to go and bring up a new server, because you've got to get the network guys right, then the storage guys have got it right, and they messed up the SAN, and then they've got to get the server right, and all that coordination and processes is fundamentally behind much of the enterprise's problems. Try the nifty button. Look at that. So we asked this morning about cloud and what's the definition. I wasn't allowed to answer because I already have mine, but I think that, let me build this out, that there are three aspects here which is really, how cloud is different and how cloud is different from virtualization. The first thing is the empowerment of, the end user. And in much of cloud, the end user actually is an application developer. They're the ones who actually want to consume the enterprise's services, and they want to do it in a self-service manner. So they have a catalog of services that are offered to them they can consume, and they want to be able to request those and to get a response happening there in an automated fashion. The automation is important. We showed one of the examples here this morning was ING, and what they've done around their application consolidation. I had a very interesting discussion with a CTO, or at least a chief architect from that organization, about automation and how they view it. And what he said to me was that, automation is actually a cornerstone of auditability and security in the environment. Because without automation, if as you're setting things up, if you've got people logging into machines, making changes to configurations, bringing them online and so forth, you've got to then have some other people coming in to check that, are all the settings okay? When they logged in last time, did they change the settings and now causing me to have a compliance issue? And so a way around a lot of the costs involved in compliance is to actually automate your deployment so that there is no one who is touching that machine. In fact, no one can touch that machine, and what's happened in that environment can then be traced and logged and happen in a repeatable manner. Now, the final aspect of cloud computing is the fact about delivering optimally. And in fact, the delivering optimally aspect is why much of the processes in the enterprise exist today. So, I don't know, I guess many of you are familiar with sort of the IT processes in many enterprises that include, the daily hour-and-a-half meeting, which is like, here's the stuff we're going to do today. If anyone sees anything wrong, please speak up now. That meeting. And so what those meetings are about is, if I make this change, if I bring this new service online, am I going to impact anyone else in the environment? And everything is hand-tuned, everything is hand-managed, and such, to get something deployed, people are really individually curating requests almost to get them in place. With cloud and with automation, there is no individual curation. And so one of the complexities of this environment is that you need to be able to deliver an incremental piece of service to an end consumer automatically and not interfere with anyone else. And that's why the cloud infrastructure and setting up a cloud, even though it might use the same servers and the same networks that you used before, same storage, is different, because you have to be able to deliver incrementally, automatically, but in a way that is not going to go and disrupt anyone else. And so that, is generally talked about from multi-tenancy, is a sort of a word that comes in to describe that. And we're going to dig into all this some more as we go through. Now, Shane brought up this one as well. It's all about applications and workloads. And this is absolutely what it's about, because what you're trying to do is you're trying to incrementally deliver pieces of application and pieces of workload from a shared infrastructure without disrupting anyone else. And so you have to understand what it is you're deploying. You have to understand where you're getting the resources from to meet those workloads. And that is actually causing people to really understand more about what they're doing, which they haven't had to do in the past. In the past, the discussion with IT was, I need 5 new servers next quarter, and they've got this many gigabytes of RAM, this many cores, this much network. That application got that server. If it used 50% or 40% or 20% or 80%, it was contained within that server. Now, where everything's shared, you've got to be much more concerned about how individual workloads, what their demands are on the application, how you'll meet them. I'm going to dig into this a little bit more. The other thing that's happening in this world is the open source software revolution. And there's 2 adages about this, and this is part and parcel of the cloud. The first of all is, the enemy of great is good enough. All right? I can get some open source software. Mightn't be might have all the bells and whistles, but you know what? It does the job. Actually, it's a very interesting proposition for many people. And people, as they're looking to re-architect their applications for cloud and the components they'll use for it, open source seems a very interesting target. And the second part of this is, actually the enemy of good enough is free. So, how can I make do with this open source software to deliver a very, very scalable application? Because if I'm a company looking to create a new cloud app, I go and look at what some of the biggest internet providers are doing. How do they build their cloud applications? How do they put them together? It's all open source. Yahoo, Google, all these companies actually have not only use open source, but they publish their stuff into open source, so other companies that are just smaller organizations starting to build cloud type applications are starting to use that same software. And this is actually revolutionizing a great deal, particularly in the world of big data.
Nigel, can you explain, you went back one slide, and could you explain why you think that's happening? Because that's changing business. That's changing process.
And there's two reasons, right? So first of all, I mean, I know companies that have commercial databases, right? They look at the cost that of that software, which is charged by core, costs them annually, and they are so horrified by that cost generally, they will put a circle around those licenses and those machines in the data center to basically maximize the return from their license investment. So it's not trivial amounts of money they're spending. At the same time, as they're looking to build these very, very scalable applications that are increasingly internet focused, again, they look at, well, what's the architectural pattern for building those applications, right? And so they'll go and have a look at the published patterns from the big providers, and all these open source names start to come up. And so they go, well, it works for them, can we use that same pattern? And they're going, so it's cost, it's, and I'll show you some examples of this a little bit later on. So as I said, the database area is absolutely huge, and particularly as we look into big data, this is all key. There's commercial products there, and Vertica and so forth is amongst them, but there's also a great deal around distributed file systems and databases and object stores, where this software, if you benchmark it, it's really, really good, and there's all different categories of software. But if you are an application developer who's looking to create a new application, you can find real nice pieces in there that you can use to put your very, very scalable application together. And here's an example I got from someone as to how you put together this open source software to build a very, very, very scalable application for an enterprise. And this was taken from a real enterprise's example, but essentially what you do is you can, for example, start off here. You've got huge amounts of requests coming in from the internet, and social media components that you're mining and so forth. First thing you put in the front of there is memcache to basically start to answer the trivial questions very simply. Open source software. Then what you do is, you use sharding strategies. What you're trying to do then is, as requests are coming in, you might have some open source software here which doesn't scale particularly well, not to the level of your business. So what you do is, you just replicate a whole lot of servers. Each have got their own copy of that software, and each are handling loads from a subset of your customer population. And CPUs and storage is cheap enough that you can actually do that. It's a lot cheaper than buying a very large database that can handle all that traffic, in a large cluster and so forth. So this is getting a lot of the incoming requests, a lot of the catalog browsing, a lot of the inquiries that people are making around your products and services. And then what you have is a back-end set of applications. This is your shopping cart that, when you finally go to make that purchase, is going to go into a back-end series of systems for the sales and inventory allocation and shipment and so forth, as well as your own internal staff maybe using that to look at what's happening in the environment. And again, this may be somewhere where you're using your traditional environment, your traditional databases, your traditional computing structure that's running those core financial processes that Shane talked about that really aren't leaving your data center. And then, at the same time, you're probably trying to do some analytics on the customer behavior. So what are they looking at online? What do they then purchase the next day in store versus completing the transaction? So they abandon the transaction online and come into the store. You want to do some big data mining out of what's going on there. And so there's a lot of copying, there's a lot of Hadoop, again, open source software that you're using for this, this big data processing. So people are, building out these very, very scalable systems. They're using a combination of technologies and using open source technologies where they're applicable. They're using a combination of delivery methods. So there's aspects here where, okay, this is the private data center on traditional equipment. Maybe some of this aspect about responding to tweets and doing some of the initial part here, that'd be great to run in the public cloud. And so, as they lay out these types of application architectures, there is a movement towards, a natural movement to hybrid cloud and where those workloads can be placed and run most effectively. So this is a big driver in terms of the adoption of cloud. And again, it's the application developers who are the big drivers in all this, in this environment. And so this has to be my favorite slide. And this came from Chris Kemp. He was one of the co-founders of OpenStack, a very, very smart guy, if you read his biography. What this picture is about is, you like cloud, is the center of the picture, the center of the world is the application developer and the application. So draw that picture with the application developer at the center. And then what are the services that application developer is going to need to have available to actually go and build an application like I just showed you in the environment? And there's compute, and there's object storage and block storage, but there's also load balancing, DNSs, message queues, emails, databases, memcache. There's scaling of applications, such that as load comes in, components of that application will auto-scale. There's monitoring, there's accounting. And so this is actually a great, to me this is, if I'm an application developer writing an application, and I go to IT and say, here's what I need, this is the set of services I'd be talking about. And in fact, if you look at what HP Cloud Services has done with our HP Cloud offering, and you look at their announcements over, even up to the last few months, you'll see they're going around just ticking off all these boxes and all these circles, and that's what the public cloud is offering. It's what application developers at the center of the picture need to create this next generation of applications. And so what we talk about around hybrid cloud is delivering this type of functionality both in the public cloud, in the private cloud, in the managed cloud, all based around this same foundation. So anyway, this is some sort of context.
Pause for questions.
Pause for questions. And from this side of the room, perhaps.
No pressure.
Oh, someone did? No? No questions? I'm astounded that Tim has no questions. I'm absolutely flabbergasted that Luigi has no questions. But just to name a few. But I'll keep going. Well, let me ask you a question then, if you won't ask me one. So, is this sort of characterization of cloud, of open source software, of the application developers sort of driving cloud and cloud usage, is this like, yeah, we got that? Is this new? Is this on track? What do you think? Question.
I'll talk from the point of view as a developer.
Uh-huh.
I've developed apps on the cloud. Got me? Got me, okay. I've developed apps on the cloud, and one of the problems that I'm finding, yes, there's the open source standards where we kind of adhere to, so we can pull out APIs from different databases, data structure on the cloud to be able to get the end result that we need. What we are finding as developers is that each platform has its own intricacies depending on the delivery method and the delivery toolworks and hardware that it's going to. Perfect example. Developed an app for an iPhone. It's real simple. You're going to go into 3 types of devices: iPads, iPhones, and maybe touches, which all kind of share the characteristics.
Right.
When you start going into app development for Android or any of these other platforms that are out there, you got, now it's becoming exponential amounts of screen sizes, platforms, hardware requirements, and it's making it tough for guys like us developers to develop a bug-free, problem-free application that is useful to the masses.
Yeah.
You guys are doing your job by providing the infrastructure, but when it comes to the final endpoint, which is the end user or the corporation, that's where all hell breaks loose for us.
Yeah.
So, I mean, what can be done on the standard size, saying, developers, guys, you got to adhere to this, or manufacturers, you got to adhere to this, in order to make it, for guys like us, easier to deliver.
Yeah, I know. It's a right ones test everywhere type of thing. I mean, and it's such a problem. I mean, you've only got to look at browsers, and it's like, I mean, it's just terrible. And the 5 variant of browsers, 5 major browser variants, and just to get that right and working is a work of art in itself, right? And then you go to the mobile devices, and it sort of expands again with the screen sizes and everything else. I think, there are some platforms which sort of try to do that, and you smile because you know that they sort of do. Yeah. And I think that they do, some of the lifting, but they're not universal, and so there is. Actually, we open source this. There's from Palm OS. There's Enyo, which is a portable mobile platform, and then but there's other open source ones as well. But I think that part has really got to be an ongoing dialogue between the device manufacturers and. Well, again, I mean, I think it's. From a cloud perspective, we can help push the bits out to whatever the end client device is. The problem is, you've got to basically push out different bits to different devices because they all respond just slightly differently. And, it's fine when the user experience was, here's a form with like 5 fields to fill in, but now the fields all have that little sort of back shadow, and as you move over them, they wobble, and all that sort of user experience piece, which just gets, it's just mind-bogglingly complex.
Yeah, and my thing is, should we be thinking about the service providers teaming up with the hardware manufacturers on setting up a true standard, where everybody can kind of adhere to and knowingly plug code into this and know that their end result is going to be not as painful as the reality that it's happening.
And I think it's a little bit of the hardware manufacturers, but I think it's more of the operating system provider. I mean, it's more about, Microsoft, Google, and Apple agreeing on an HTML5 implementation that works universally. I mean, that's the. Huh?
That's where the point goes. You mentioned Google, you mentioned Apple, Microsoft. Of course, they don't have to migrate. But let's say we want to migrate as software as a service or a product as a service, and it's still a strictly manual event to do those kinds of stuff. And
yeah,
it's been a struggle for more. When you get that deep into developing services, and you want to migrate from one system to another one, of course, you work on an HP environment, it's going to be, it's going to work fine. But I have not seen anything, there's no silver bullet out there that we can actually use to migrate
Yeah.
cloud services?
Well, so I think there's two parts to it, right? So one is what's the end client device, and I think that there is a migration, a support in both the Apple Store and the Play Store and the, which and then a desktop browser, which is an issue. I think the other part is then a migration between a public-private managed cloud.
Public to private, that's manually.
Well, so I think we've got, so I'm going to show you a little bit about that in Cloud System. And so I think it's a little bit less of a nightmare, but also I think Shane is going to talk about, there's no pixie dust, but there are processes to help you move applications.
And that's what I was trying to describe before, is, I guess I'll wait for Mike. There is no pixie dust, so I'm not here to give you guys that, but I think this is where we get the tools and processes and how do we fill the last mile. So what we've done when we look at this is, and this gets to the question too, you need to both be able to define and model your application as well as your infrastructure, and you need to be able to do that separately at times because you have different platforms you want to deploy to, and the person who knows how to define and model the infrastructure target is different from the person writing the app. And so what we've tried to do is keep that in mind with our tools. And then from standards, to come back to this too, is OpenStack, which we talked about, doesn't deal with everything. There's other emerging standards like Tosca, which is on the application modeling side, which we're leveraging. But I think this gets back to its early days. And we shouldn't expect the standards to just fix everything. It's going to take vendors writing tools that leverage those, but then quite frankly, we have to fill the gaps. But we do have the ability today to let you build on a public cloud. And if you model your target environments correctly, we can pick that up and drop it on a private cloud. But you got to take advantage of the tools that are there. If you just write it all, then it's like what I said. It's like welding the application to the platform. And you need to think about that at the beginning.
Thank you. So, and we'll talk more about this afternoon. Actually, a couple of different sessions. So this is a great topic. All right, let me keep going here. I think this one is sort of starts. I mean, Shane mentioned this morning. I think this is something that I'm hearing directly back a number of times from people. Is people want to program the data center now. So they want APIs that let them go and program what's being delivered. So it's not an email describing a request anymore. It's an API call, which comes back and starts the ball rolling. And this was almost a direct quote from one of our customers. No API, no interest. That's what we're looking for in this next generation of cloud. And we'll talk about those APIs when we talk more about both into OpenStack and Cloud System and our converged infrastructure. We're working on those. So this is about some of the drivers into cloud, some of the issues around driving applications into cloud, some of the trends. Now there's the other side is the person who has to operate the cloud and provide the cloud services. I've got here, this is an is not list here. The first one is, they want it very, very simple to set up and operate. There's many providers who talk to me about wheeling in a rack and having it just plug and play with the rest of their cloud. They need to be able to deliver agreed SLAs. They need competitive price. They need operational agility. So all those things they're looking for out of a cloud. What they're not looking for is, and you can just cross out Amazon and put their name in there, about their cloud outage. And so as they're putting everything into a shared infrastructure, be it a private infrastructure or a public infrastructure, basically not being on the front page of the Wall Street Journal is a key concern to people doing this. And they're moving very, very cautiously because of that. So what we're going to talk a little bit about is what we're doing around the is list and what we're doing also to keep you out of the headlines as well. And a good aspect of that is this, we talked about these 4 delivery models. We talked about SLAs that are associated with delivery in those models. And I took here, this is just off Amazon's site, about the SLAs that they offer for one aspect of their cloud services, right? And this is their block storage volumes. Okay, so they have an IOPS guarantee plus and minus 10% of the provision performance 99.9% of the time. And I must say, HP's metrics from our cloud are usually 99.95. I'm very proud of that additional half a 9. But you know, designing your data center infrastructure with that sort of notion in mind is a different mindset. It's a different mindset to people have today. And what we're doing with our cloud offerings is providing solutions which are designed to deliver a certain level of availability. And it's a different way of thinking about what you have in the data center, how you're putting it together, and how you're structuring it. Because now what you're thinking about is, okay, what is my IOPS demand that I want to go with in plus and minus 10% for what class of application in the environment? And so we get then to, and this is probably a little bit of an eye chart. This came from one customer. We talked about different workloads in their data center, and there's a question.
Yes, I thought of this after you passed the API slide, so forgive me for backing up a little bit. But would you consider the automation and the do less with more thought process of companies driving that API integration? You know, companies wanting the APIs to do less with more?
Part of it is doing less for more. I mean, part of it actually comes back to, and I'm going to skip way back here, is going to come back to this slide. Because, you know, basically these engineers here, or these people here going to the catalog, I mean, we show them from a catalog and pressing buttons and everything there. In reality, these are developers, and it's not so much the button that they're pushing, but it's Puppet and Chef that are pushing, because they've gone and you know, submitted a new piece of code up into their repository. It triggers a build, it triggers, you know, some other actions that are going on there. And so what they really want to do here is they want APIs exposed from the data center so they can actually build an end-to-end delivery process for their applications. And so it is about doing less with more, it is about being more agile, but it's also, I think, a sort of a revolution of the application developer groups who need to get business results out, and they're saying, give me an API to the data center, and I'll give you that app. You know, I'll give you that change you've asked for this week at the end of my agile delivery cycle. If you wanted me to type 5 emails giving a request, it's going to be a month. And so that's sort of why this API piece is coming down. It's really about, I mean, cloud is about exposing an API to the data center, essentially.
You mentioned Puppet. Does HP utilize a lot of Puppet, like Puppet Labs technology?
I think, like all companies, you'll find that there's some Puppet, you'll find there's some Chef, you'll find there's some other tools. I mean, I think across HP there's a lot of different tools that are used. I think that, and Shane will tell more about this, but generally what we're about is choice, because HP uses a set of tools, and you know, we know and love them. We'll go to another customer who says, we've standardized on Puppet. If you can't do Puppet, then you know, thank you for coming round. So we need to provide that choice to the customers, and certainly those OpenStack tools are part of the choice points that we have. And yes, we do have integrations of those, and Shane will talk about those. So anyway, let me skip forward here. We got a question. That's wonderful. If I can just, there is no going back. Let me go back to this slide here. This is another one of my favorite slides because the customer actually knew enough about their workloads to actually start to characterize what their resource needs are. And it's surprising how many companies you go to and you say, what are your workloads? And they have absolutely no idea. And that's, part of the issue about moving to cloud and sharing resources is you've got to know what it is you're trying to share and what you're trying to do. So they've got a characterization here of from how many cores that they're going to give a VDI job, how much RAM they're going to give a VDI job, and then they've also got here, very interestingly, minimum commit rates for IOPS and for bandwidth across classes of application. And so, when you look back at that from the provider side, yes, I'm going to deliver plus or minus 10% of the committed, whatever metric it is, 99 point, and how many nines you're going to commit to, they can start to generate a pool of resources that provides that guarantee, and then, with some sort of characterization of workloads, start to look at, okay, that means I can do 10,000 VDI jobs in this section of the cloud, and so on. And so there's really a lot about here getting a characterization of demand, and then starting to think about your data center being a pool of resources which can deliver in an automated fashion to a given SLA. And so I also know a number of customers who have, if you like, a number of internal private clouds, and those alternate private clouds each have a different SLA attached to them. And what they'll do is, as a job moves between development through testing into production, they'll go to these different clouds because at this stage they want to have a particular SLA guarantee that underlies the environment on which those workloads are running. So anyway, it's a good characterization here. It's about pools of resources that you're going to draw from. It's also very interesting here to look at the profile of hypervisors. And this was a particular source. It's in places here you can substitute out Hyper-V and VMware depending upon a particular customer's preference. But what you find is that people are very interested in KVM in certain aspects or certain parts of their life cycle. There are other ones where they have, I've talked to them specifically about it. The answer for this application workload is it will run on VMware. And part of that is enterprise licenses, part of that is just what they've decided to do for the next few years. And so when we look at building a cloud and building choice in the cloud, we need to support multiple hypervisors. We need to support bare metal, because that's still important for types of workloads. And so, it's this type of need which drives you then to how you build your cloud. And again, it's a little bit about software, but it's also a little bit about the environment as well. I don't know how that worked. So we'll talk a little bit about converged infrastructure, which if you look at our architecture is the piece on the bottom. And converged infrastructure is really about transforming your view of the data center from a set of servers and a set of storage and network and so forth that you're individually handcrafting and putting them together for an application stack into instead pools of resource. And the characterization of those pools of resource are some sort of capacity limits. So for storage, it's terabytes and IOPS. For network, it's megabits per second and latency. For servers, it's gigabytes of memory and cores. And so fundamentally what we're doing is we're designing resource pools which sort of have an interconnection, but which also can provide those resources with a view of multi-tenancy. When I started to talk about this, you have a self-service request, you say I need another 5 VDI endpoints, you want to do it without impacting the utilization of others. So you need to be understanding then from your infrastructure what you have available in these sorts of metrics and appropriately scheduling consumption of those metrics from your infrastructure in a way that's non-conflicting. So I'm going to pause it now for, is there any more questions on here, or am I going on time here? Getting close.
10 more minutes.
Yeah. So any more questions on this? So pools of resources.
We can talk about conversion infrastructure later on and stuff.
We do. We'll dig into actually how we implement all this, but what I'm trying to do is set up why pools and pools of resources are important. Okay. All right.
Do you have a number or something that you can provide us as far as how much SAN servers are, how much storage is being covered on, talking worldwide, how much storage you guys are or have as far as your clients, and how much do you cover for this client? Let's say, I don't know, it could be Amazon or RackShare or all these companies that HP provides SAN servers for them. I know that SAN servers and storage is a big business thing for you guys. So can you give us like an example how much storage you guys have out there?
I mean, I don't know the aggregate amount of, I mean, basically it's saying how much aggregate 3PAR do we ship a year, for example, how many petabytes of 3PAR do we ship? Shane, do you have any idea what that number would be? I mean, it's definitely a big number, but we'll have to find out what that number is. I mean, it's huge. And I think I'll talk a little bit about some of our other storage solutions. I mean, you know, you can get pretty much from a density perspective now, you can get in excess of a petabyte in a rack. We ship a lot of racks, so I mean, I guess is it Google bytes or something? I mean, but we'll find out what that number is. I got someone in storage who can probably tell me.
We have a storage session tomorrow.
Okay.
When we go to Agudia,
Well,
it'd be a great question to ask.
Yeah. But you know, it's very large, and I think that the key to storage is, I think also 2 metrics. It's how much do you actually ship, so how many disks do you sort of send out the door. I think the other one is how much do you offer to the virtualized resources. And so, and we'll cover this a little bit in the converged infrastructure talk tomorrow, but you know, when you think about things like thin provisioning, when you talk about aspects like caching, particularly on a server side, what you can find is that, you know, one image can serve, you know, tens or hundreds of virtual machines. So that 1 gigabyte or 10 gigabytes, let's say, is per machine served is 100th of that. So we'll ship a certain amount of physical disks, but actually how much storage we're providing to the cloud could be 10 times or 100 times that amount because of features like thin provisioning. So, but we can get you that figure. All right. So, what we've talked about here is some of the aspects here. So there's drivers. There's demand from developers who are trying to build these hybrid patterns that combine open source software, traditional software, cloud models, traditional infrastructure models together to build a particular application. We've got the next aspect of this is that in order to deliver these resources, these workloads, we need to, you know, structure resources into pools, pools of capacity. And then we need to actually have a cloud environment that someone can bring into their data center, have operate at a given SLA level, and a given sort of supportability level so that they're not on the front page of the newspaper. And so how HP addresses bringing all that together in a known way is our cloud system products. And so we have a portfolio of products that are a solution, a cloud solution that combines the network, the server, the storage, the management together into one package that you can buy as a known quantity. You can support so many virtual machines, so much capacity because it's a known tested quantity. And we have a range of offerings that start from basic infrastructure as a service to Cloud System Enterprise, which has the application delivery and the application lifecycle components, right through to something for a service provider. And so 3 scales of offering, 3 scales of SLA and cost point, 3 scales of capability from infrastructure up through applications that customers can pick and buy and have something that have a resource pool that's a known quantity that can deliver a set number of workloads. And so we have these offerings set, and one of the things I'm going to talk about is those offerings and how they're constructed and the features they have, particularly around supporting choices of hypervisor across different hypervisor, across bare metal, different storage and networking subsystems, and then also, linking to the application management session that Shane will give tomorrow.
Hey, Nigel, maybe we just call it there, because I think this is a kind of a stopping point.
Okay. Let me just leave one last slide here just to pin this. Was actually my last slide. So this is where we're going to stop. I just wanted to just a little bit talk about, I should have done it on the slide here. So we're going to talk about this overall stack in more detail today. Hopefully I've laid out a lot of the issues and problems and components that we're trying to solve in building a cloud. And we're going to be digging now into these components to let you understand then how we actually are building that end solution. And so from top to bottom, we're going to start, is it the next, or is it networking the next session?
Networking next.
Okay.
Next.
The session after next, we'll start from the top here with Shane, and he's going to talk about the portal experience. He's going to talk about the application management, the security, the development tools aspects, which is the top part of this picture. It's going to dig into how those developers and how those processes and lifecycle changes, solutions that we have in that space to bring together the hybrid cloud experience. Then we're going to talk a little bit later on about this cloud platform here. This is the infrastructure as a service portion. We're going to dig more into how Matrix provides those resource pools. We're going to talk about how it relates to OpenStack. And then we're going to have sessions where we're going to talk both this afternoon and tomorrow about the converged infrastructure which supports all those. So how the server, the network, and storage components actually deliver into that solution across those 3 aspects of cloud. So hopefully this gives you a framework. We'll be coming back to this picture as we go and work around these layers so that you can put all the picture together. Hopefully this has given you a sort of a foundation here as to how we're looking at the problem and the solution.
Okay, so maybe a little bit theoretical for some, but again, it is the foundation for the next 2 days. So we wanted to start here, get that entrenched with you guys, and then we can move on further.